Allison. I'm one of the youth librarians at Skokie Public Library, and joining me today is...
Desi!
Today, I am excited to talk to you about something colorful, light, and full of joy. Something that I think everybody loves.
Mac and cheese?
Fair point. But no, today we are going to be talking about bubbles.
Oh, I love bubbles!
See? Everybody loves them. But do you know what they're made of? And don't say
The rainbow-colored dreams of unicorns?
No. Though I can see how you might think that. Remember when we talked about saponification?
Oh, I wish I were a little bar.
Yes. So a bubble is just air trapped inside a layer of soap film.
I know, I was just messing with you. Soap film is a thin mixture of soap and water.
It's really cool. The inside and the outside surfaces of the bubble are made out of soap molecules, and in between them is a really, really thin layer of water.
It's a soap molecule sandwich!
Soap molecule sandwich. So those layers, the outer layer of soap with the inner layer of water, work together to contain the air. So they're basically soapy floating air pockets.
Rainbow-colored unicorn dreams does sound better.
Yeah, I hear ya. Maybe I haven't 100% sold you on soapy floating air pockets, but I might have something that could help.
Is it a song?
You know what I always say.
If you sing a catchy song,
You'll never get it wrong.
I think that I shall never see such iridescent sorcery. It's evident when you appear. There's magic in your floating sphere. Where you wish magic as you see a unicorn's delightful dream.
I mean, that was really good. But bubbles, bubbles everywhere. You're just soap film filled with air. Not unicorns, majestic jewels. You're water and soap molecules. But on this fact we both agree. Bubbles fill our hearts with glee.
Okay, fine. I'll admit that they may not come from unicorns.
But if you think about it, bubbles are pretty magical. For example, not only are they fun to pop, they prove that air is matter.
Of course air matters. Without air, we couldn't breathe.
Very funny. No, I mean that air is matter, and it takes up space in the same way that you or I or this ukulele take up space. Think about it. The soap film is just a thin skin until you put air into it.
Oh, I get it. Like how an empty bag doesn't take up much space until you put stuff into it. Okay, that's cool. But is it unicorn magic cool?
Well, if the very air that gives us life isn't exciting enough for you, don't worry, I've got more tricks up my sleeve. And you can try these experiments at home. Desi and I mixed up a bubble solution of our own, but you can also use the kind that you buy at the store. For our recipe, we used soap, water, and glycerin. Glycerin is a substance used for saponification.
That's soap making!
It sure is. And in bubble mixture, it helps bubbles last longer. Think about why they pop.
You touch them or they land on something dry.
That's right. Dry surfaces are the enemy of bubbles. But look what happens when you wet your finger or a dry surface.
Bubbles are happy to hang out.
That's right. That is, until the water inside the soap sandwich evaporates and then...
Pop!
Glycerin helps to keep the water around a little bit longer.
Thanks, glycerin.
All right. For our first experiment, we're going to take this triangular wand and dip it into our mixture. What shape do you think the bubble is going to make?
Aren't all bubbles spheres?
You're absolutely right. You can use any wand shape you want. And when you're blowing a bubble, it can make all kinds of interesting shapes. But as soon as you stop blowing and the bubble seals, it immediately forms a...
sphere!
That's because once it's sealed, the tension of the soap and water molecules shrinks into the smallest possible shape to hold the air inside. Of all the shapes, Spheres are the most efficient for holding this type of matter.
What about this cube shape? I'm guessing if we blow a bubble through it, we'll see spheres.
Yes, but what's exciting about this is what happens to the soap film.
Oh, wow! It's a cube within a cube. Is this because the soap film wants to take up the least amount of space?
It is. The soap film is elastic. You can stretch it and move it around, but it wants to be as efficient as possible. In this case, it's taking the form with the smallest possible area within these constraints.
For our final project, we are going to see how many bubbles we can add to make a bubble chain or bubble caterpillar, and we challenge you to do the same.
Remember, bubbles like to take up the least amount of surface area, and sticking together means that they can share space. It's very efficient.
Try to make a family record and then see if you can break it. Thanks for making unicorn dreams
Soapy floating air pockets.
with us today, science friends. We will see you next time.
Until then, as the great William Shakespeare once said, bubble, bubble, toil and trouble.
Unicorn dreams!